Good. Alright, MTS, ALG2, homework 10.3, 19 through 29. Now we're going to actually do 19 through 39, but right now I'm getting through 29 really quickly. So, 19 is, we're going to translate this into radians. Okay, so we could turn 240 into radians just by looking at my pi, right? If I look at my my wheel over here, my what's that called? Unit circle, right? I can see 240, and 240 is really 4 pi over 3. Done. Now that's if you have the unit circle. You might look at it and go, how did he do that? Well, because I went over here and I'm looking at it going, oh, that's 240, which is 8 pi over 6, because that's 8 pieces of pi over 6, which is 4/3, right? But another way to do it is upside down division, right? So I can say, well, what goes into 240 and 180?
24.
How about 10?
10.
Okay? So 10 goes into there, let's say 24 pi and 18, right? So I'm going to rewrite that up here. So it's 24 pi over 18. What goes into 24 and 18? 2?
2.
6? Oh, she said 6, he said 2. I believe 6 is the key. 2 does work though. 2 would go in there, right? 12 times and 9 times, and then 3 goes in, right? Or we just do the 6. 6 goes in 24 4 times. 6 goes in 18. 3 times. Oh, there it is. 4 pi over 3. Ta-da! Little bastard than we did earlier, right, Nathan?
Yeah.
Alright, let's do the next one. What goes into 25 and 18? Somebody, anybody, one buddy. 25 and 18. 5. Good job, Nathan. Alright, how many times does 5 go into 25? 5 times.
It's negative 5.
How many times does 5 go into 18 or 180? 36, very good. How do you get 36? He said 5 goes into 18 3 times with 3 left over. And 5 goes into 30 6 times. And that's it. Done. Done, son?
So basically just like
Just reducing the fraction. Yeah.
Is it like greatest common factor?
Greatest common factor. Yeah. Alright, so when we do from radians to degrees, right? We want to multiply by pi, the 180 over pi, because we want to get rid of the pi's. So what can we pull out? Well, we pull out a pi. Thank you. I'll eat that. Never mind. So then we got 180 over 9 left, and it's negative. So what goes into 180 and 9? 9. How many times? Like negative 20 times, right? So that'd be negative 20 degrees. So, I'm here all day. Okay. So then what? Well, we got another pi we're going to take out of the oven. Yum, yum, yum. I'm gaining too much weight from all this pie. Okay, not funny yet? Alright, so then we're going to pull out the 7 times the 180 over 2. And then I can pull out what?
A 2.
A 2. And a 2 comes out at 180 how many times? 90. So we're talking about 7 90s, right? 7 90s. What's 7 times 9?
6, 30.
630 degrees. And says, watch this, what? Ready? And he drops the pin. I'm on fire.
Wait, so that's how you do it 2 degrees?
Yeah, that's how you do it to degrees. Pretty simple, right? So going from radians to degrees, we use 180 over pi. When going from degrees to radians, like the top, we use pi over 180. Okay? Trying to think of a good way to remember that. I just haven't gotten a good way yet. I'm trying.
I just need 29.
29. Well, first we're going to do 27. But first I should erase this. And not this. Because you're not done copying it, right? Never mind. Okay. You're so crazy. You're a crazy man. Yes, you are.
He sounds like the grammar for more.
Alright. We're ready. Alright. To do these, we want to know so, ka, toa. Right? So just like I said before, you want to be able to write this down immediately when you're taking that SBAC. I mean, you sit down to take the SBAC as soon as you can write. You say, can I write something on my notes? And they say yes. You want to do what? Draw the unit circle. Right? It's really easy. You make a circle. You break it up into 4 pieces. That's 0, 90, 180, 270. Then you make it up into 4 more pieces. 45, add 45, add 45, add 45, right?
Yep.
Then you cut this piece, boop, this piece, boop, this piece, boop, this piece, boop. And then you're like, yeah, and blah, blah, blah. And then put in your 30s, right? And that's your unit circle. Doesn't it look perfect?
Very much so.
Yeah, not really. But at least I have it to start with. And I know where all my 30s, 60s, 90s are, right? And I know, then I can count my pies. I'm going to have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7. So 6 pi, right? 6 over 6 is 1. So I'm going to have, when I get to here, I'm going to have 1 pi. 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi. I'll have 2 pi. So I'll have pi and 2 pi, right? And then I put all my other stuff in, my 45s. That's going to be 1 out of 4 pieces. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, pi over 4, 6 pi over 4, 7 pi over 4, 8 pi, and then I'd be done. Right? And when I'm done with that, the first thing I do is so, ka, toa. Okay? Because once I have the so, ka, and toa, I can put it down like this. Oh, that's sine. Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Toa, tangent. Opposite over adjacent. After I'm done with that, I'm not done. I got to put in cosecant. Right? Co goes with no co. What does that mean? Dan always says co, no co. I don't know what the F he means by that. Right? Co, no co. Co, no co. What does he mean? Kid's tripping. I'm never going to get this done. Well, if you do it, you'll get it done. Co, no co. What does that mean? Does sine have a co in it? Is there a co in sine?
No.
No. So that means the thing that goes with sine is cosecant. See how it has a co in it? Cosecant. Sine. One has a co, the other one doesn't. They are inverses, so it's the opposite. It's hypotenuse over opposite. This is how you do it. Right? No, okay, never mind. Alright, so back to cosine. So cosine and secant. Does cosine have a co in it? Yeah, right? Secant, right? Cosine, secant. Secant does not have a co in it, does it?
No.
So it goes with cosine. You see what I mean? Co, no co. Co, no co. And cotangent and tangent, they just go together like white on rice, right? Or like white on meat. Oh, what? What? Alright, so then you got tangent and cotangent. Okay? So those are opposites. They're inverses. So opposite over adjacent, adjacent over opposite. You have it written down, and so now when you get to that part on the test, like it says, hey, I got tangent at 300 degrees. Okay? Now I want you to do it. I go, well, that's easy. I'll put it in the calculator. And it says, well, yeah, you don't have a calculator. Do it anyways. And you say, how am I supposed to do this without a calculator? And I say, easy. I think about the unit circle, and I think about where 300 degrees is, right? Where is 300 degrees? We know it's right here, right? We already learned how to draw that last week, right? We can draw 300 degrees, right? And then we think about that, that is 60 degrees, right? From 360. So our reference angle is 60 degrees. So we think, oh, this is a 30, 60, 90 triangle, right? And so we have this other piece right here. We know that this is 60 degrees, right? So we know that this is a triangle, right? It's one of these, where the small side is 1,
Oh.
right? The longest side is 2. And the middle side is square root 3. Very good. Right? And so this is what? 30, 60, right? 90. Okay? So when I look at this, this is the same as this. And when it asks me, what is the tangent of this? It's saying, what is the tangent of 300 degrees? It's really, this is opposite, right? Over adjacent. But, it's not just this over this, because on the unit circle, where is it? It's right here. This side is negative square root of 3. Because it's going down, right?
Yes.
Down in the y direction. It's going positive in the x direction, so this is still 1, but this is negative square root of 3. So when I plug this in, I have, what is it? Tangent is opposite, so opposite is negative square root of 3 over 1. So done, son. Negative square root of 3. And I didn't need a calculator to do it. I needed my unit circle. Okay? That's why it's so important to be able to draw that unit circle. So on the test, you will be required, just like last year, to draw the unit circle. And how many of you had it on your cheat sheet last year? Right? Okay? Now, how many remember how to draw it this year?
Draw what?
Exactly. So, you might want to take a little bit more note on it and understand it a little bit better. You have to understand how to draw the unit circle. Let's do the next problem. Cosine 5 pi over 6. We got to think about this. 5 pi over 6. That's less than 1, right? 5 pi over 6 is less than 1, right? Right? And we already know that this is 180, right? And we also know that this is pi, right? And so we break this thing up into 6 pieces. 1, 2, right? 1, 2, 3, 4, 5, 6. And you said it's 5 pi. It's 5 pi over 6. 5 pi over 6. That's how many degrees it is, right? But the reference angle, well, that's this guy, right? So the reference angle is this. Because we always deal with the reference angle. That's why we're figuring out the reference angles. Okay? So when we look at this triangle, we're really looking at this reference angle. How big is this reference angle? Anybody, somebody, one buddy. Come on.
45.
No, not 45. Remember, 45 gets broken down in fours.
180?
No?
30.
30. It's one piece of pie. It's 30 degrees. It's 30 degrees. Good guess. Right?
I didn't guess.
You didn't? You do it? Okay. So it's one piece of pie. It's 30 degrees. Okay? We also should know, if we wrote it, we know that this is 30, 60, 90, 120, 150. And 150 is how far away from 180? 30, right? So no matter what, we should be able to figure this out. The key is this, though. I still have to know my 30, 60, 90 triangle. The short side is how much? The short side, this is 30. You're right, but what's the side? How much is that? 1. Good. How much is the longest side, the hypotenuse?
2.
2. I always got it confused too. Guys, you have to know this. I still get it confused. Okay? But 2 is longer than the square root of 3. It doesn't seem like it because you're like, it's 3. 3 is bigger than 2. Right? But it's the square root of 3. Alright? 2 things that multiply to be 3. What's 2 times 2? 4. So that's bigger than the square root of 3. See what I'm saying? Something that multiplies itself to get you 3 has to be smaller than 2. Does that make sense? Alright, so that's kind of where we're going. Now, it says cosine. I have to know SOHCAHTOA. If I don't know SOHCAHTOA, I'm screwed. This isn't going to work for me. You feel me? Alright, don't feel me yet. Alright, so let's go with what? Cosine. Ca is adjacent over hypotenuse. Right? So, adjacent. So let's look at it. This is opposite, right? This is adjacent. And this is what? Hypotenuse. Okay, so it's adjacent, which is square root of 3 over how much?
2.
The hypotenuse, 2. Good. And that's it. Done, son. Bam.
Wait, does that say log?
Did I make it? No, it doesn't say log. I might have got a little sloppy. It says OPP. Opposite, right?
No. The 29. Does that say log 5 pi over 6?
Cosine. This?
Yeah.
No, it says cosine.
Okay, that's better.
COS. Okay.
What's H for hypotenuse?
All right, we're good.